This is our physics set. In the previous class, we discussed about light reflection, refraction, few important points like reflection. So how it will be there? Incident ray, a reflected ray, normal line. So when the light is incidenting on it, it will be reflected back. So I am recalling all the topics whatever we discussed in the previous class. So here you can observe. I am considering this the topics. Okay, so whatever we discussed in the previous class, we'll recall first, then we'll go to the next topic, whatever topic we are going to discuss today, right? Yes. So now you can observe, in the previous class we discussed about, so plane mirror is there, so plane mirror I am considering, so light is incident on it, so it will be reflected back. So the line which is perpendicular to the plane surface, that is the normal line. The angle between incident ray and normal line is called angle of incidence. Angle between reflected and normal line is called angle of reflection. So the line which is deviating through the surface is called deviated line. The angle between reflected and deviated line is called angle of deviation. So this is about incident ray, reflected ray, normal line, plane surface. This is a plane mirror also we can consider, and also we can take a reflector, that is also known as reflector. Okay, it is a reflector. So you can observe here. So this is the incident ray, reflected ray, normal line, plane surface. So the entire phenomena is known as the bouncing back of the light or reflecting back of the light is known as reflection. Yes, right? Yeah. So if you take linear surface, I am taking this linear surface. So linear angle is 180 degrees. Linear angle is 180 degrees. So if you take this entire angle, so angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. We know laws of reflection. So from laws of reflection we can get to know. So angle of incident is equal to angle of reflection, right? So angle of incidence plus angle of reflection is angle of reflection plus angle of deviation equal to 180 degrees. 180 degrees. So you can observe angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So by that, so we can take angle of incident plus angle of incidence plus angle of deviation equal to 180 degrees. Angle of deviation equal to 180 degrees. So we can write this one 2 angle of incidence. So here you can take a 2 angle of incidence plus angle of deviation equal to 180 degrees. 180 degrees we can write. So angle of deviation equal to 180 minus 2 angle of incidence. 180 minus 2 angle of incidence we can take, right? So that is about the angle of deviation formula. Once again you can see here, I am taking this incident ray, reflected ray, this is a normal line. Okay, incident ray, reflected ray and normal line we can consider. So linear pair is 180 degrees. Linear pair is 180 degrees. So that's why I am taking. So this entire angle is 180 degrees. So angle of incident plus angle of reflection plus angle of deviation equal to, so here from here we can take 180. So we know from laws of reflection angle of incident equal to angle of reflection. So I can consider this one. So we'll get angle of deviation equal to 180 minus 2i. 180 minus 2i. So that is about the angle of deviation. Angle of deviation. Next one, regular reflection and irregular reflection we'll discuss. Regular and irregular reflection we'll discuss. So what is the regular and irregular reflection? So I am taking regular reflection means if you take the plane surface, this is a plane surface, so the light which is incidenting on it. So if the light is incidenting, the reflected beam is parallel to each other. If the reflected beam is parallel to each other, that is called regular reflection. So if I am taking this is a smooth surface reflection, regular reflection takes place on smooth surface. If you take irregular reflections, so when the light is incidenting on it, so incident beam is parallel but reflected beam is not parallel, so not parallel to each other. So then this type of reflection is called irregular reflection. This is called irregular reflection. Irregular reflection. So this is the irregular reflection. So understood? Regular reflection and irregular, the difference is regular reflection takes place on smooth surface whenever the light rays incident on it, so reflected beam is parallel to each other, whereas irregular reflection takes, here you see regular reflection, so irregular reflection takes place on rough surface, so reflected beam is not parallel to each other, reflected beam is not parallel to each other. Do you understand? Yes. So now we can take object and image. Once again, I am recalling all the topics whatever we discussed. So object and image, if you are taking, so this is the plane mirror I am taking. So object, from the that light rays are coming, right? So if you take, so this object, from this object light rays are coming, after reflection it is reflected back. If you extended those light rays are meeting, extended light rays are meeting at one point, that is called virtual image. So this is the real object. Okay, point of intersection of incident light rays is called real image. The point of intersection of incident light rays is called real image. The point of intersection of extended incident rays, extended reflected rays. So here you can see this is the point of intersection of extended reflected light rays. So these are the reflected light rays. You can observe this is the reflected light rays. Here also down you can see these are the reflected light rays. We are extending this reflected light rays. Those are meeting at one point. Okay, so their image will form, that is virtual image. So here you can observe, here there is a real object. Understood? So that is about the real object and virtual image. So if you are taking one more, so I am taking like this, light rays are coming from infinity, so after reflection the light rays are coming from the object we can take. So after reflection light rays are meeting at one point. Okay, so incident light rays are meeting at one point, that is a virtual object. So directly reflected light rays are meeting at one point, that is called real image. So we can observe here this real object, virtual image, real image, virtual object. So we can conclude that by this, if the object is real, image is virtual. If object is virtual, image is real. So okay, these notations are very important. So you can note down, very important. So you need to remember. So in exam they will ask. Okay, so very important topic. So try to remember all these points. And next one will go with the next topic is characters of the image formed in the plane mirror. So what are the types of characters formed in the plane mirror? We'll discuss. So now we can see, I am taking, so this is a plane mirror. I am taking this a plane mirror, right? Yes. So I am taking the object here. This is the object. From this light rays are coming. So one light I am taking like this. Okay, so is it visible to you? So you can see here. So one object I am taking. So this will be incidenting. So I am taking like this. Object is here. One light I am taking like this. Why object is like that? Yes. So this is the object. One light I am taking like this. It will be reflected back. So another light ray we have to take from here. So how many light rays are required to form the image of the minimum 2 light rays? So one light I am taking. Another light I am taking like this. It will be reflected back. If you extend this light rays, so here image will form. So this is a virtual image, this is the real object. Okay. So characteristics, what are the characteristics? Image formed in the plane mirror is virtual, erect and same size. The distance between object to mirror is equal to distance between mirror to image. So size of the object is equal to size of the image. Size of the object equal to size of the image. Okay, it also forms lateral inversion. What is the lateral inversion? If you stand in front of the mirror, if you lift your right hand, it appears in the left side. If you lift your right hand, it appears in the left side. If you lift your left hand, it appears in the, if you lift your right hand, it appears in the left side. If you lift your left hand, it appears in the right side. This sideway conversion. The sideway conversion is known as lateral inversion, right? So I hope it is very clear. Now, so we'll discuss a few points related to this one. Few questions we'll discuss related to this topic. Just carefully observe. So what are those? Question number 1. Define reflection of light. So what is the reflection of light? Define reflection of light. Define reflection of light. So what is the reflection of light? We can see reflection of light is nothing but, so when the light is incidenting on the surface, it will be reflected back. So I am taking this one, when the light is incidenting on it, it will be reflected back. So this is a normal line. So then the bouncing back of the light or reflecting back of the light is known as reflection of light. So next question is state two laws of reflection. So second question is state two laws of reflection. So we have to discuss about second question. So they are asking about two laws. What are the laws? So angle of incident is equal to angle of reflection. So I am taking here this reflecting phenomena, light is incidenting on it. So angle between incident ray and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. So angle of incident, first law, angle of incident equal to angle of reflection. Second law, so incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. So these are the two laws of reflection. Next one, define regular reflection and irregular reflection of light. So next question is regular and irregular reflection of light. So what is the regular and irregular reflection of light? So we can see regular means, so when the surface, smooth surface if you take, incident beam is regular. So then reflected beam is also parallel to each other. So incident beam is parallel, reflected beam also parallel, then this type of reflection is called regular reflection. Coming to irregular reflection means, so incident beam is parallel, reflected beam is not parallel to each other. So I am taking, so this is a rough surface, previously I took a smooth surface, so here rough surface I am taking. So incident beam is parallel like this, parallel I am taking, okay. So reflected beam is not parallel to each other, so it will move in a different directions. Then the type of reflection is called irregular reflection, or also called diffuse reflection. This type of reflection takes place on a rough surface, okay. Next one, list the characters of the image formed in the plane mirror. So just now I discussed, so I am taking the plane mirror here, so I am considering the mirror object, I am considering here. One lighter I am taking here, another lighter it will be move, sorry, not here, yes, one light ray, so it will reflect, another light I am taking, it will reflect it back. So here one more light ray, okay. So if you extended these light rays, here it will be meeting. So by this we can understand, what we can understand. So the image formed in the plane mirror is virtual erect and same size, same size. So the distance between object to mirror is equal to distance between mirror to image. So u equal to v, and also, so third point is it follows lateral inversion. So what is the lateral inversion? The phenomena converting of right side of the object appears to be left side of the object appears to be right side. So this phenomenon is known as lateral inversion, right? So this is about lateral inversion. So this is about today's topic. If you like this content, do like, share and subscribe to Student the Brand. So we'll go with the next topic in the next class. So if you have any doubts in this class, so just comment below, so I'll reach to you, okay. So in the next class also you can ask. So this is about light reflection diffraction. Thank you so much.